Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi. Kita sambung lagi berkenaan dengan perbincangan kita berkenaan dengan integrations by substitution. Kali ini kita akan tunjukkan contoh berkenaan dengan function yang melibatkan exponent function base E untuk kita selesaikan dengan menggunakan kaedah substitution. InsyaAllah dalam video ni saya akan tunjukkan 4 contoh kesemuanya. Okay. So kita mulakan dengan contoh yang pertama. So sebelum tu dalam video ni insyaAllah saya akan share sedikit tips bagaimana pemilihan U substitutions untuk setiap function apabila melibatkan exponent function. Contohnya dekat sini, kalau kita ada integral of x times with e to the power of x squared dx. Okay. So kalau kita notice dekat sini, kita ada dua function. Yang pertama kita ada polynomial dan kita ada exponent function. Apabila melibatkan dua function ni, satu polynomial dan satu lagi adalah exponent, so untuk pemilihan u kita akan ambil the power of exponent sebagai u substitution. Okay. So lagi sekali, kalau melibatkan function yang polynomial dan juga exponent, so kita akan ambil the power of exponent sebagai u substitution. Contohnya dekat sini, kalau saya ambil now we let u is equals to x squared. Okay, then we differentiate u with respect to x, we will get 2x. Okay, 2x, and then cross multiply, kita akan dapat du is equals to 2x dx. Then we are going to divide by 2 for both sides. Then we are going to have half du is equals to x dx. Alright, katakan kalau saya rewrite this function again dalam bentuk integral of e to the power of x squared, okay, times with x dx. Okay, sebab this is actually multiply, it is a commutative law, so kita boleh lakukan darab di sebelah kanan ataupun kiri. So saya boleh tulis dalam bentuk macam ni. So we can see that this x dx, okay, this x dx, we can simply substitute with half du. Okay, and for x squared we just replace it by u. So in order to change in terms of u, kita akan ada integral of e to the power of u times with half du. Okay, and then since half is a constant, so kita boleh keluarkan. Then we will have e to the power of u du, and then integral of e to the power of u with respect to u, we're supposed to have eu, is it? Okay, so we are going to have 1 over 2e to the power of u plus with arbitrary constancy. Then kita gantikan balik u tadi dengan x squared. Kita akan dapat e to the power of x squared over 2 plus with arbitrary constancy. Okay. Baik, untuk contoh yang kedua, iaitu B, contoh B, we have a functions of e to the power of x over 1 minus e to the power of x. This is actually types of ratio, and if you notice, on both numerator and denominator we have a exponent function. So untuk yang case macam ni, kita akan consider seperti mana contoh yang saya tunjukkan dalam video yang pertama, di mana kita akan pilih on denominator sebagai use substitution. Okay, so dalam case ni memandangkan kedua-duanya adalah exponent. Okay, dan juga kalau kita tengok dekat sini, kedua-duanya mempunyai degree yang sama, dan kita akan memilih on denominator sebagai u substitution. So now we're going to let u is equals to 1 minus e to the power of x. Then we differentiate u with respect to x. We're supposed to get minus e to the power of x. Then by cross multiply, we will have negative e to the power of x dx. Then we divide both sides with minus 1. Then we will have minus du is equals to e to the power of x dx. Okay, And also I'm going to rewrite this function as integral of e to the power of x dx divided by 1 minus e to the power of x. So daripada sini kita boleh nampak yang mana e to the power of x dx, okay, we can simply substitute with negative du, and for 1 minus e to the power of x we just substitute with u. Okay, then in terms of u, we will have integral of negative du divided by u. Okay, so since negative is a constant, saya boleh keluarkan. Okay, we can kita boleh keluarkan daripada proses of integral, dan kita akan dapat negative integral of 1 over u du. Okay, so we have 1 over u, which is we're going to have negative ln absolute u plus with arbitrary constancy. Then kita gantikan balik u tadi dengan 1 tolak e kuasa x. Kita akan dapat negative ln absolute 1 minus e to the power of x plus with arbitrary constancy. So this is actually for B. And kita tengok contoh yang C. Okay, so we still have a ratio function e to the power of x and over set x. So we notice that on our numerator we have a exponent function, and on denominator we have a polynomial functions. So since we have a polynomial and sorry, so this one supposedly set x. Okay, since we have exponent dan juga polynomial, as usual we are going to select the power of exponent, the power of exponent sebagai u substitution. Okay, now we are going to let u is equals to set x. Okay, then we are going to have du over dx equals to half x to the power of negative half. Then cross multiply, so saya simplify, half x to the power of minus half will become 1 over 2 times with set x dx. Okay, then by multiplying both sides with 2, okay, saya akan dapat 2 du is equals to 1 over set x dx. Okay, so again I'm going to rewrite this function as integral of e to the power of set x times with 1 over set x dx. Okay, so this 1 over x dx we can substitute with 2 du, and set x we just substitute by u. Therefore we are going to have integral of e to the power of u times with 2 du. So 2 is a constant, we took out, we got integral of e to the power of u du. Then we are going to have 2e to the power of set x plus with arbitrary constancy. Okay, and lastly example D. So the same as example B, both functions are actually exponent function. Then we are going to select this on denominator as a u substitution. Okay, so we're going to let u is equals to e to the power of x plus e to the power of minus x. Okay, then we are going to have du over dx is equals to e to the power of x minus e to the power of minus x. Then by cross multiply we're supposed to have e to the power of x minus e to the power of minus x times with dx. Okay, and again rewrite this function as integral of e to the power of x minus e to the power of minus x dx, and this is actually over e to the power of x plus e to the power of minus x. Okay, so this one is actually du, and for e to the power of x plus e to the power of minus x we just substitute by u, and then kita akan dapat, sorry, this one dx, kita akan dapat integral of, sorry, So kita akan dapat integral of du divided by u, which is, we can also rewrite this as integral of 1 over u du, which is kita akan dapat ln absolute u plus with arbitrary constant c, then u kita gantikan balik dengan e kuasa x plus e to the power of minus x plus with arbitrary constant c. So this will be a final answer.